So now we're going to do a little bit more difficult of an example of a Lewis structure, and this example is going to indicate how shared equals need minus available may not give you the best Lewis structure, so you have to start to expand your knowledge of Lewis structures and use an additional concept, an additional rule, in order to come up with the best Lewis structure. So just to review, let's do the first 5 rules for drawing a Lewis structure. 1, identify central atom. 2, draw skeleton. 3, count electrons. 4, shared equals need minus available. 5, fill in lone pairs. And now we're going to add a new rule to factor in the fact that shared equals need minus available may not give us the best Lewis structure, and it'll help us figure out what is the best Lewis structure. So in order to get the best Lewis structure, we need to minimize formal charge. Okay, so step 1, central atom. This is the atom that we have the least of, sulfur, so that's going to be our central atom. Draw skeleton. We have 1 S and 4 O's, so we're going to have O's hanging off of the S. There's our skeleton. Step 3, count electrons. Well, the oxygen has 6 valence electrons, and the sulfur also has 6 valence electrons, so that's 6 times 5 is 30 electrons available. But also, you need to account for the fact that this means that 2 extra electrons got stuffed onto this molecule. So we actually have 30 plus 2 electrons, 32 electrons available. Alright, next step, shared equals need minus available. The need is we have 5 atoms, and each one needs an octet. So we need 40 electrons. The available, we just did the work on that over here, is 32. So the shared is 40 minus 32, 8 electrons. And because each bond is made up of 2 electrons, 8 electrons is 4 bonds. So according to shared equals need minus available, this molecule is going to have 4 shared bonds. And we see that here in the skeleton. 1, 2, 3, 4. So now we're going to fill in the lone pairs. So now you can see that we have the lone pairs all filled in, and if we count them up, we have 2, 4, 6, 8, 16, 24, 32. So this is a valid Lewis structure because it has, everybody has their octet, and all of the electrons that we had available have a home. But the problem with this Lewis structure, what makes it the not best Lewis structure, is that there's a lot of formal charge on this molecule. So each of these oxygens usually has 6 valence electrons, but as drawn here has 7. 2, 4, 6, 7. So each one has a charge, a formal charge of -1. And the sulfur usually has 6 valence electrons, and as drawn here has 4. 1, 2, 3, 4. So it has a formal charge of +2. So this molecule, the formal charges add up to -2, which is the charge here. But there are 6 units of formal charge on this molecule, which is a lot of formal charge. It is not stable. So we're going to add a new rule, the minimize formal charge, in order to get a better Lewis structure. So we want to find a way to move this formal charge around so that we have less units of formal charge in our overall molecule. So the starting way to do that is if I take these electrons here and I move them in, I can get rid of the formal charge here and reduce the formal charge here. Now, sulfur can violate the octet rule because it has access to the d orbital because it's in the 3p block of the periodic table. So, once we draw these electrons having moved in, what we get is and then the formal charge on each of these, this was -1, now it's 0. This is still -1, -1, -1. This is now +1. So the total units of formal charge on this molecule is now 4 instead of 6. Much better. But we can do even better than this, right? Because if we move another set of electrons in, we can minimize formal charge even more. So if I move either these ones in, or these ones, or these ones, it doesn't really matter, just pick one, I'll move these in. What I get is, I'm going to draw the resonance arrow, what I get is this. And here I have a -1 formal charge, here I have a -1, this is 0, this is now 0, and the sulfur is now 0. So the total formal charge on this molecule is -2, and the total units of formal charge on this molecule is also -2, which means we have minimized formal charge. And so that because we have managed to minimize formal charge, we have come up with the best Lewis structure. So when you're doing these Lewis structures with an expanded octet, you need to not just think about shared equals and need minus available, but you also need to think about how can I minimize the formal charge.